Hey guys, so we're going to go ahead and kick off chapter 1 with 111. It's all about functions, inputs and outputs, and also stacking functions, along with evaluating them. So for the first example, if you have an equation, for example, k of x equals 2x plus 3, and I want to find k of 2. So you can already tell that instead of k of x, I've replaced that x with a 2 in the parentheses, which tells me that I'm going to need to do the same in the equation. So where I have written an x, I will write a 2 instead and leave everything else the same. So by our order of operations, we know that we would have to do multiplication before addition. So where I have 2 times 2 plus 3, I have to take care of that 2 times 2 first, and then bring that plus 3 down. Then I end up with 4 plus 3, and that's going to give me a final answer of 7. Alright, number 2 is the same exact idea. It's p of n this time. You can literally use any letter, it doesn't matter. It won't always be x's and y's. So this time it's 2n squared minus 4, and I have to find p of negative 8. So that tells me I'm going to write down everything about that equation, except instead of n, I'm going to put a negative 8 everywhere that I see an n. So now, again, according to my order of operations, my negative 8 has an exponent of 2. And here I see that e, which stands for exponent, comes before like all of these other things, including multiplication, subtraction. So I have to do the negative 8 squared first. That's going to give me a 64. So now I end up in a similar position to the first one, where I have multiplication and then subtraction. Well, m comes before s, so I'm going to do this part first. 2 times 64 is going to be 128. Bring down my minus 4. And that's going to give me a final answer of 124. Alright, I'm going to leave number 3 for you guys to do, but I am going to do number 4 because it's a little bit different from what the first 3 are doing. So notice that this time the question is a little bit different. In these, I replaced x in the parentheses with a new number, and we had to plug that number in. However, this time they're saying find x when r of x equals 20. Well, we know right now that r of x equals 3x plus 5. So what this is telling us to do is take what we know as r of x, which is this, and set that equal to 20. Once we do that, we just have a basic equation to solve, which is all stuff that you've done in Algebra 1 as well as geometry. So to reverse my order of operations and get x by itself, the first thing I want to do is move that 5 away. Our goal is eventually to just isolate x, make it so that x is the only thing on one side of the equal sign. So moving 5 away is going to be the most helpful thing we can do right now. That ends us with only 3x on the left side, and 20 minus 5 gives us a 15. So now we have a 3 times x equals 15. So to get rid of this 3, we need to do the opposite operation. So if 3 is being multiplied by x right now, we need to go ahead and divide both sides by 3. That's why we subtracted up here, because initially it was a plus 5. So dividing these by 3 makes that 3 go away, and we end up with a final answer of 5. And we got that by doing 15 minus 3. Alright, so finally we're going to go ahead and see what stacking functions look like. We're going to start with an input of 16. So kind of like what we did in these first two problems, we're going to take the number 16 and insert it into a function. We're going to go f, g, h, and then k. So I'll plug 16 in for x, and that's just going to give me an answer of 4 because I took the square root of 16. So now, for stacking functions, I'm going to take the solution I just got and put that into my next one for x. So now I will have everything in that equation, except instead of x, I'm going to write 4. Okay, 4 minus 2 is going to give us 2. And so this is going to give us an answer of negative 4. All right, on to the next one. We're going to now take negative 4 and plug it in for x in this h of x equation. So 2 to the negative 4 minus 7. If you do 2 to the negative 4 in your calculator, you'll get 0.0625. And remember, we have to do that first because it's an exponent. And that 7 is just going to come down as normal. And then once we subtract 7, we get a negative 6.94. I rounded to the nearest 2 decimal places, but really the full answer would have been negative 6.9375. But 2 is enough for our purposes here. And then finally, we're going to put that last answer into our final function for x. Watch out for those double negatives there. Know that a negative times a negative equals a positive. Okay, so the first thing I want to compute is this fraction right over here. So this negative times negative equals a positive, so that tells me that my first term is going to be a positive number. It's going to be a 3.47. And that minus 1 is just going to come down as normal. Okay, now we can just do the regular subtraction and end up with a final answer of 2.47. And again, this is it's a rounded decimal, which is just fine for us. Okay, and when we stack functions like that, it's actually something called composite functions. And the correct notation for it is like this. Notice how we went f, g, h, k, and in here, we went inside out. So it went f inside, then g, then k, then h. And then, in fact, that should be written the other way. So good thing we caught that now. All right. And that is it for 111.